Hello again, and welcome again to the Hanover Messe Hydrogen Fuel Cells, Batteries, and Group exhibit. My name is Robin, and this afternoon I will be speaking with Thomas J. Stephenson, who's the CEO and Chairman at Pajarito Powder. Thank you very much for joining us. Welcome. Hello.
Hello.
Hi.
Thanks.
Thank you. And our topic for this afternoon is maximizing value with engineered carbon supports. So first of all, I will ask if you can tell us about what it is that Pajarito Powder does.
Sure.
In the US of A, I should say.
Right. So Pajarito Powder makes a couple of products. We make engineered catalyst supports and precious metal-free catalysts. The materials look just like this, and they're intended to be included in PEM fuel cells. We also have some additional development work that we're doing for electrolyzer catalysts. Those are not yet released to the marketplace, and so we have the two core products, the engineered carbon support or ECS materials, along with the precious metal-free or PMF materials.
Thank you. And what is the importance of what Pajarito Powder does specifically in relation to carbon?
You know, carbon to us is the unsung hero in the fuel cell. For the longest time, everyone understands that the cost of catalyst is a huge impediment to the widespread adoption of fuel cells. And if you look at the projections for large volumes, 500,000 automobiles, for example, FCEVs, it's expected that the cost of the catalyst is going to be 45% or more of the overall cost of the fuel cell. And the emphasis to date has always been around what can we do with the platinum? How can we make the platinum particles smaller? How can we change its geometry? How can we do other things to the platinum? Yet, very little attention has been put on the fact that platinum is only part of a catalyst system. The other part of that catalyst system is the carbon. And carbon, which has been widely regarded as just a commodity that you put the platinum on top of, is where we focused our attention and time to be able to develop engineered carbons that are very specifically designed to work within a fuel cell and improve how the platinum performs, which will allow you to get higher performance, longer life, and then ultimately allow for lower costs in the entire fuel cell stack. And so we view carbon as a great hero for the next generation of improvement in bringing down the cost and improving the performance of the fuel cells for PEM fuel cells.
Thank you. And so moving on to my next question, if you can tell us about your products. The most I hear about is two of them.
Well, right. So we've got the two products, and primarily our focus today has been on the engineered catalyst support, which is a primarily carbon-based product for which either we or our partners will deposit platinum, and then that becomes the catalyst that goes into the fuel cell system. And it's designed for the PEM fuel cells, primarily for the automotive applications, for the higher power density applications. We also have an entire family of products that we call these precious metal-free catalysts that are completely free of any platinum or other type of precious metal component, and they are very much suitable for lower power applications because they provide the best performance in terms of a price per kilowatt of power produced, but they don't have the power density that's typically required for applications such as automotive. However, for CHP, for stationary and backup, conceivably the precious metal-free catalysts are still very much a strong candidate.
So what makes your products different than others in the market at the moment?
Well, it really is the fact that we've focused on engineering the carbon from the ground up. We don't take a carbon and modify it. We actually construct the carbon. We use organic precursors and other materials and run them through a series of manufacturing steps, all of which are highly scalable, which we do at our factory in Albuquerque, New Mexico, in the U.S. And that allows us to not only create a carbon material that's designed to work in a fuel cell, but also allows us to have a highly customizable material. So our proprietary Veripore process, which is what we use for the manufacturing of our materials, both our PMF, or precious metal-free materials, and our engineered catalyst support, allow us to fine-tune a lot of the characteristics that are important to our customers in terms of pore size, surface area, particle size of the overall catalyst. And so it's that customizability of it that allows us to really tune into the specific needs of our customers and provide these advanced characteristics that they need, coupled with the precious metals in the case of the automotive applications, to allow them to achieve their performance and cost targets going forward.
We have a lot of time.
Yeah, right.
So what about challenges? In particular, maybe something to do with demonstrations. What challenges does the market or Pajarito encounter?
For us, as a proud part of the fuel cell industry, we face all of the challenges that everyone in the fuel cell space faces. I think one of the things, and that is the growth and availability, the overall market adoption of particularly the fuel cell electric vehicles, which will be driven a lot by policy, but one of the things in particular that has been kind of a challenge for us that we think is something that the industry needs to look very closely at is too much emphasis on demonstration projects, and in particular too much emphasis on demonstration projects that don't have a market-driven economic component to them. So time and again, what's going to ultimately cause the market to move to fuel cells, to alternative energies, is going to be the achievement of something much closer to cost parity with, particularly in the transportation sector, for solutions that are driven by conventional energy sources. Now, this is a huge problem in the United States where our energy costs are extremely low, but it's true around the world that time and again we see projects that are intended to demonstrate the technical viability of fuel cells, which we have moved past. I mean, they're judging from the number of companies, the level of sophistication and maturity of the market. We can make fuel cell cars and fuel cell buses and stationary applications. It's very possible. The key now is to achieve that economic level of parity, and we need to start to see more demonstration projects or more sort of real market-driven projects that understand that you've got to achieve those cost targets. For us, this is critically important because our real value proposition is in being able to bring down the cost of the fuel cell. Our target and our projection at volume is that for the automotive application, we can take $10 per kilowatt US out of the cost of the fuel cell, which is just about the gap today that the industry needs to achieve in order to hit economic viability for the 2020 targets. But until we start to turn that discussion in other sectors of the fuel cell space around what do the economics look like, and are we really producing projects and opportunities that will be driven by markets, we're going to continue to be limited. And so for us, I mean, that's one of the same challenges that ultimately I think the entire industry faces.
Yes, you keep hearing about that. Any questions from the audience at this moment? Not quite yet. So as we all know, the U.S. has a new president. We'll say that. And so I just wanted to get sort of like a bit of an idea of what...
Did we elect a new president?
You may have. That may not be as on the same path as the past one was as far as green energy goes. So can you give us maybe an opinion or maybe like an overall idea of what's going on?
Yeah, there's no question that the current federal administration in the United States has made it very clear that they intend to de-emphasize efforts around renewables, and in particular, and I think this is what's sort of critical for our industry, certainly for us specifically, but for others, is a de-emphasis on funding for basic research and early applied research into alternative energies, including hydrogen and fuel cells. This is obviously directly a problem for any U.S. companies that are in the space, but also I think because the Department of Energy has been such a key component in funding the next generations of technologies and new opportunities in fuel cells and hydrogen and other forms of renewables, that any pulling back from that will ultimately have an impact on the industry. It's uncertain the degree to which that's going to happen. We do have the very broad policy statements from the administration in that regard, but we don't know how that will manifest in terms of sort of specific funding opportunities and other types of projects. But on the flip side, I can tell you that for fuel cells specifically, the #1 market within the United States has been and continues to be the state of California. And the state of California has made it abundantly clear, it's stated in public, that they believe in climate change. They believe in combating that that. They believe in the importance of improving air quality, and they are going to continue the high level of emphasis on the development and deployment of renewables, particularly in the transportation sector that we've seen in their policies in the past. And so today in California, roughly, the formulas are more complicated than this, but roughly 10% of the cars that get sold have to be zero emission. There's no indication that they're going to change that in terms of reducing it. And in fact, if anything, our expectation is that in the near future they're going to increase that. And so California continues to go its own route based upon the California's leadership. There are a number of other states in the United States that will also who have a similar philosophical view and will also be able to continue to work towards renewables because of the importance of that market that gets led by California. So, there's no question that reductions in funding, which are going to come, are troubling to all of us in the industry, and that's disappointing to see. And hopefully, we will see some change in that as we continue to educate members of the current administration on the potentials, particularly over the long term, of the economic benefits, the energy security benefits of fuel cells specifically, and alternatives more broadly. But there are some challenges that we face because of that. There's absolutely no question about that. So, but America's still open for business. So. Yeah.
Thank you, and thanks for addressing that question. So on that note, speaking of projects, can you tell us about any projects that you have coming up or contracts?
So one of the things that we're very excited about, I alluded to this earlier, is that we've started to move into electrolyzer catalysts. In Europe in particular, we've seen tremendous emphasis on the use of hydrogen for energy storage, the ability to convert renewables into hydrogen through the electrolyzer process. And so one of the projects that we do have through the U.S. Department of Energy, and they have continued to assure us that projects that have been funded will continue to be funded, is for alkaline electrodes for electrolyzers. And so that's a project that we're working on in conjunction with the University of New Mexico, in Albuquerque Northeastern University, in Boston, Massachusetts, IWI, also in Albuquerque, and Proton On-Site, now part of NEL, hydrogen based in Connecticut. And so we're very excited about that project. We're into the second year of it. It will be some time before we'll have commercial products associated with that. But I think that will be ultimately something that will be very beneficial for the industry. All focused on bringing down cost, which is really what we're all about in everything that we do.
So then that's as much as you can tell us about that project.
Well, yeah, that's right. That's I mean, that one. Well, I could tell you more, but it would be a little bit beyond my my technical capabilities. I'd have to bring our CTO up here to do that. So okay. It is a Department of Energy RPE project, and so that one is public, and we'll be continuing to talk about it as we're going along.
Perfect.
So.
Well, they can just visit your website or come to your booth as well to speak to hear more about
Absolutely.
that. So what's next? What's sort of the overall outlook, or what's happening next for Pajarito Powder?
So our team is incredibly excited about the prospects for fuel cells and our ability to have an impact on the industry. One of the things that when we introduced the engineered catalyst support products actually here at Hannover Messe last year, since that time we've had almost every one of the automotive companies who is involved in a serious way in fuel cells start to go through a qualification process with our products. And so our team is very excited about how we've been moving through that qualification phase to ultimately get into end-use systems. Because we're a component supplier, for us the big volumes come after a stack manufacturer and system provider ultimately decides that they're going to include the products in their designs. And so that's a long process, but we've been making great progress against it, and that's something the team is very, very excited about. And I think for us, it's very clear that that the take-up for fuel cells, particularly in electric vehicles and electric vehicles more broadly, is just accelerating. And my prediction is that we're on a pace that will actually eclipse what people had been thinking 5 or even 3 years ago. And I think that's driven a lot, not only by the issues around climate change that have been codified in the Paris Accords, but the increasing level of attention that's going on to the challenges around air quality, particularly in the great cities of the world. And so it's our feeling that the cities like London and Paris and Stuttgart, cities in Asia like Beijing, Shanghai are going to really drive home the requirement to move to complete zero-emission vehicles, and as a result, we're going to see a huge growth in electric vehicles broadly, which means, as the automotive industry understands, that ultimately we're going to need to see a huge adoption of fuel cell electric vehicles. Hydrogen station refueling infrastructure continues to be a challenge, but that comes along with investment, and again, the cities, we think the great cities of the world are going to require that. The solution is going to have to include fuel cell electric vehicles, which the automotive industry understands, and we're really excited to have our own part in being able to change the economics to make it economically viable for those companies to deliver those products to the marketplace.
Thank you very much. We have a question I can see over here. 1 second.
You started to answer this question actually in the last answer, but I wanted to ask more about, I guess the development process. That if you're a fuel cell manufacturer and you want to integrate one of your catalysts, what does that integration process look like? The validation process look like?
Well, so any time we fit as a catalyst provider into their MEA production process, which will then be integrated into the stack. And for the MEA production, there is a fair bit of optimization that goes on anytime they adopt a new catalyst system. And so what happens is that typically we work very closely with the MEA production component, whether they're an integrated provider that does their own MEAs and their own stacks, or there's someone who provides MEAs that they then turn and sell commercially to the fuel cell stack providers. We will be involved in an iterative process with them to provide our materials, to have them do optimization, to get their feedback so that we can make these changes that I was describing around the characteristics of the catalyst support in order to optimize it from our side and provide the highest performance possible. And so that's one of the things. At first there's an optimization process that goes on, which is related to the validation, because ultimately what they're trying to find is end up with an MEA that has the highest performance, and in particular the highest durability in the case of the automotive applications, to allow them to move forward. And so it's a multi-year process, longer in the automotive industry. We'd always like it to be faster, but it's something that we work with them where they try it, report back. We have conversations about modifications both to the MEA production and also to the catalyst production that ultimately leads us through. So it's not as simple as here, take this and drop it in. I mean, we do talk about this being as close to a drop-in replacement as possible because we want it to not require a redesign of the overall stack architecture or the way in which they make MEAs, which is certainly the case, but there's always optimization that has to go on.
Thank you for that.
Sure.
Our thanks. Thank you so much for joining us.
Thank you.
It's Thomas Stephenson, from CEO and Chairman at Pajarito Powder out of the United States of America. And so they are in booth B76, which is basically the first booth when you walk in on your left. So please feel free to stop by if you have any more questions.
We're the closest to the gelato stand, so that should make a high incentive in the afternoon to
Make
come
sure
by.
to stop. Are you buying gelato? Is that where this is going?
It depends on the level of interest. We'll consider it. So.
Excellent. Well, thank you so much for joining us.
All right, thank you, Robin.
Thank you. Thanks. Up next, my colleague Brian will be speaking with Dr. Hans-Jörg Fell, CTO at Hydrogen Pro, and the topic is launching the world's largest electrolyzer when size and performance matters. Thank you.